Today's topic is properties of definite integrals. Properties and formulas in any topic is very easy to memorize, but the challenge lies in their application. When you see any question, how do you decide which property or which formula is going to help you find a way out? That is what we are going to learn today. We are going to see some properties of definite integrals, and we are going to do some questions and examine how and where to apply our properties. So we start with the first one. What does the first property say? We have a function in the variable x. For example, sin x. The same function but in a different variable. Let it be theta. Now integrate both of them within the same limits, a to b, for example. This is what your first property says. These two will be equal. That means if your function is same, if your limits are same, then the variable does not make any difference. Be it sin x or theta or r or m or whatever. If the function and the limits are same, then the variable does not affect the integration. This is your first property. And what does the second property say? It is about interchanging the limits. Now, what if the lower limit becomes the upper limit and the upper limit becomes the lower limit? Second property says that in this case, the magnitude of your answer will be same, but it will have a different sign. That means if this is minus 4, this will be plus 4. If this is 4, this will be minus 4. This brings us to our third property. What does it say? You have a function. You are integrating it within the limits of a to b. Now suppose we take a c in between these two. Between a and b, you take a c. Then you can split the integral from a to c and then from c to b. But now the question is, what use is this property to us? Where can we use it? This can be used only when fx behaves differently in a to c and it behaves differently in c to b. Why would it do that? Take any function, fx is equal to say 2x. Then if x is equal to 0, fx will still be 2x, right? Fx will be 0. And if x is equal to 1, this will be 2. But then for no value of x, 2x is going to become minus 2x. Or for no value of x, 2x is going to become 4x. Right? This is your function. So the function may take different values, but the function itself is not going to change, except for which are the ones you have studied. Remember the modulus function, remember the greatest integer function. Those are two functions which behave differently for different intervals. So whenever you see a greatest integer function or you see a modulus function, this is the property which is going to help you find a way out. I'm sure you remember them, but just let me refresh your memory. Whenever x is positive, then it is x itself. But whenever x is negative, it becomes minus x. So that is the function. That is your modulus function. So from 0 to infinity x, from 0 up to from 0 downwards to minus infinity, it will be minus x. Now how does your greatest integer function look like? Your greatest integer function is defined like this. If x lies in the interval n, where n and n plus 1 are integers, in this interval it always gets mapped to the lower limit. What does that mean? Take any n is equal to, say randomly, take n is equal to 2. What does that mean? The greatest integer less than or equal to 2 is 2 itself. What is the greatest integer less than or equal to 2.5? That is 2 itself. What is the greatest integer less than or equal to 2.9? That is also 2. It goes on up to, I don't know, like 2.99999. That also falls back to 2. This goes on up to 3. For 3, the greatest integer less than or equal to 3 is 3 itself. So this particular interval does not include 3, but right from 3 all the way to 2, all of the number just slide back to the lower limit. So how does your function look like? Randomly, I'll take 1 here, 2 here, and we will see. See, 2 gets mapped to 2, but then 2.5 also gets mapped to 2, 2.6 also gets mapped to 2, until you come at 3. 3 is not included. This will be your graph. So you see what I have done here? I have not included 3. That is why I did not shade this figure. Only this figure is shaded. That means only 2 is included in this particular interval. You see here, this is a strict inequality. N plus 1 is not involved. But then where does 3 go then? 3 goes here. Again here. So that is why the greatest integer function is also known as a step function. You see the discontinuity here, and if the same question, if it comes in continuity, and if you are asked is the greatest integer function continuous, the answer is no. And where are its discontinuities? At every integer. At every integer, if you take this particular interval, you will see all of them slide back to the lower limit. All of this slide back to 2, all of here slide back to 3, then here all of them will slide back to 4. That is your greatest integer function. So what do you have? You have so many. The function takes so many values. It takes 1, 2, 3, 4. It takes every integer values. So now we are going to examine some questions based on modulus function and on greatest integer function, and we will see how to apply this theorem. 1 to 2 3x dx. So tell me, what all values can x take? X will lie between 1 to 2. But what is our function? Our function is 3x. So 3x will lie between what? It will lie between 3 to 6. Right? Just multiply throughout by 3. And how many integers are there in between 3 and 6? There is 4 and 5. So from 3 to 4, everything will slide back to 3. From 4 to 5, everything will slide back to 4. From 5 to 6, again to the lower limit. Then how will your function look like? Your function will be, whenever 3 is between 3 and 4, all the values slide back to 3. Whenever it is between 4 to 5, it will slide back to the lower limit 4. Whenever it is between 5 to 6, it will slide back to 5. Again, there are no x here. So we don't have to worry about this. But what about here? 3x varying from 3 to 4. But 3x is not our original variable, right? Our original variable is x. And we can't change our limits. Our limits has to be 1 to 2. It cannot be 3 to 6. So we cannot take the values of 3x. We have to integrate it within the limits of x. So how do we make this x? Divide throughout by 3. Then 1 less than or equal to x, strictly less than 4 by 3. Then again 4 by 3 less than or equal to x, strictly less than 5 by 3. Again, see, now this is your new function. You have fx which behaves differently. From 1 to 4 by 3 behaves differently. From 4 by 3 to 5 by 3 behaves differently. So this becomes your new function, and we are going to integrate it with respect to this. So what is your fx? From 1 to 4 by 3, it is 3. from 4 by 3 to 5 by 3, it is 4. From 5 by 3 to 1, it is 5. So on integrating, it is a constant, right? So on integrating, you will just get a x. Here also you will get an x. Here also you will get an x. So you see here, all the difference is 1 by 3. 1 minus 4 by 3 will be 1 by 3. This will also be 5 by 3 minus 5 by 3 minus 4 by 3 will also be 1 by 3. This will also be 1 by 3. So therefore 1 by 3, add all of them, 3 plus 4 plus 5 would be 12, right? So your answer is 4. So this is how the property that you just now learned, that is how this helps you. Now we come to the second question. What is the second question? You see the difference between the second and the third question. One deals with addition of modulus and the other deals with multiplication of modulus. So obviously there must be some difference in the way we approach it, right? Let us see what it is. What is the second question? We are integrating from 1 to 4, and what are the functions? Modulus of x minus 1, x minus 2, x minus 3. Now tell me, what are the values of x for which the function fx is going to change? What are the values? If your x, you have to decide if your x is greater than 1 or less than 1. If it is less than 1, you will have a negative answer. In this case, then what will happen? X minus 1 will become 1 minus x. Similarly, you have to check if your x is less than 2 or greater than 2. If it is greater than 2, fine, this will just be x minus 2. But if it is less than 2, it will become 2 minus x. So the values which affect your function are this. Then here you go to infinity, and here minus infinity, and here infinity. But then the good news is we don't have to consider such a big interval. Why? Because we are only considering x, which varies from 1 to 4. So the good news is we don't need this. We will just write a 4 here. There, done. Now about the number line. As you go towards the right, the values become higher and higher. As you come towards the left, the values become lower and lower. So what do you have here? You have a number which is greater than 1. So that means what? Greater number minus smaller number will be positive. But then look at this x and 2. This is the smaller number. You are going forward, so 2 is the greater number. So then what happens? You are doing smaller number minus greater number, in which case it is negative. If you take x minus 3, again a smaller number minus a bigger number, so this will also be negative. So now your new function in this range, in the range 1 to 2, what happens? It is not this function. It has changed. Now what is this? It will be 5 minus 1 is 4. 4 minus x dx. This becomes the new function for all the values which lie in this interval. Now if you find this complicated, all you have to do is randomly consider any number. Consider 1.5. So 1.5 minus 1 will be positive, but 1.5 minus 2 negative, 1.5 minus 3 negative. So you can consider that also, but this is a more general method. So now what is the next thing that you consider? You consider the numbers from 2 to 3. Now you are considering a number here. So this is the number. So this number minus all the numbers below it to the left will be positive, because that will be greater number minus a smaller number. But this x minus any number to this side would be would be negative. So that therefore you will have 3 minus x. So that would be 3 minus 3. Yeah. So this will just be x. Now consider a number in the third interval x. X minus any of the number to its left will again be positive. X minus 1 positive, x minus 2 positive, x minus 3 positive. So 3x minus 6. This will be your function from 3 to 4. It will be 3x minus 6 dx. So there you have your function. Now integrate it. What do you get? Here you get 4x minus x square by 2 plus x square by 2 so this would be 4 into what are the values? 1 to 2, right? So 2 minus 1 would just be 1 minus x square minus 1, 4 square minus 1 would be minus 3 by 2. Here 3 square 9, 9 minus 4 would be 5 by 2. If you calculate, you should get your answer as 19 by 2. Now in this question we deal with product of moduluses. You see here the difference. Here we have actually a sum of modulus, and we will see how this question is different. What is x cube minus x? It will be x into x square minus 1. That would be x minus 1 and x plus 1. So the first one would be from minus 1 to 0. What happens there? Positive, which means what happens from 0 to 1? Negative. That means x minus x cube. What happens in our third function, in our third interval? Again positive. So this is what your function becomes. In each of these intervals, it behaves differently. So let us integrate it and see. From minus 1 to 0, you integrate this, you get x square by 2, and then here x raised to 4 by 4. From the interval 0 to 1 plus x raised to 4 by 4 minus x square by 2 by the interval 1 to 2. We have to take each, if it is sum, we have to consider each one separately. But when it is product, we don't have to consider each one separately. We just have to find how they behave when multiplied together. Now look at the third, our fourth question. So one is a polynomial, it is x, but the other is a trigonometric function. So what do you have? You have two different, in the number line itself, the Cartesian plane itself, you have two different planes. You cannot just fit everything as polynomials. That is what we are going to do next. We are going to mix up one polynomial and one trigonometric function. This is our question. So again, what do we do? Modulus function. So we have to check where all does x give positive values. It is very easy. If x is positive, it is positive. Then look at this. Here the graph is very simple. For modulus x, we don't have to worry about infinity and all. We just have to worry from minus 1 to 3 by 2. So in this interval, it is negative. In this interval, it is positive. So in this interval, all you have to take it minus x sine pi x. Here you have to take x sine pi x. So finished, right? But then what about the sin pi x? You have to find its value also. Then the whole system will change. Let us see how that happens. We take an entirely different graph. How does the graph of sine look like? The question is, if your x varies from -1 to 3 by 2, how does it affect sin pi x? So we are not talking about x, we are talking about pi x, which means how does pi x act between minus pi and 3 pi by 2. So I have just drawn the sine function just for clarity. You can just look at the graph and see what is happening. What is happening? From minus pi to 0, do you see what is happening? It is down. It is in the negative y direction. It is below here, no? So what do you see? Sine pi x is actually less than or equal to 0 in which range? From minus pi up to 0. It is below. Then where do you see a rise again? From 0 to pi. So from 0 to pi, we see a rise, which means it is in the positive y direction, which means it is greater than 0. Again, you see what is happening here? This direction you see, pi is here, your 3 pi by 2 is here. It goes down. The only thing when it comes up is at 2 pi. So from pi to 3 pi by 2, it is again in the negative y direction. So again, from pi to 3 pi by 2, what happens? Your sine function is again negative. So you see how it behaves differently in 3 different intervals. But then coming back to our question, our limits are for x. It is not for pi x. So how do we get it back to x? Divide throughout by pi. Now dividing throughout by pi, it was in pi x, we got it back to our original limits which are just for x. So now we have got what sine pi x does. It changes in these three intervals. But then what you have is the product of x and sine pi x. So we have to see how x behaves and then we have to see how their product behaves. So where does x lie? It lies between -1 and 0, which means x is negative. Here x lies between 0 and 1, which means x is positive. Here x lies between 1 and 3 by 2, which means x is positive. That means x sine pi x, their product, negative and negative, positive. Positive and positive, positive. Negative and 1 positive is negative. So what do you have? From -1 to 1, it is positive. You have x sine pi x. But then from 1 to 3 by 2, you have minus sine pi x. So that is how we are going to split our interval into. This is what our function has become now. From -1 to 1, it is positive. From 1 to 3 by 2, it is negative. So now we will integrate. Keep this as the first function. Always remember one important difference between integration and differentiation. When you find the derivative of a number, its exponent keeps on coming down. X raised to 4 becomes x raised to 3, that becomes x raised to 2. But with integration, it keeps on going up. From x, it becomes x square and x cube. So keep this as the function that you have to find the derivative of. Keep that simple because its base, it's going to come down. From x, it is going to become a constant. So keep this the same it is and find the integration of sine pi x, and this is what you get. And here, instead of breaking your head over this minus, just bring this minus here. Then both these functions will become same, right? Only the values will be different because here we are applying -1 to 1 and here we are applying 1 to 3. The next property looks like this. If you are integrating a function in x from the limit a to b, then instead of that x, you can replace it with the sum of the limits minus x. So wherever you see x, Instead of that, if you add the limits and minus it from x, the answer will be same. Now where can we apply this? These are some questions where there is direct application. You can just look at the question and you will know this is what you have to apply. Why is that? In each one of this, if you notice, there are two terms. Here it is 4 plus 3 sin x, 4 plus 3 cos x. And here e raised to sin x and e raised to minus sin x. Here sin x and cos x. So in each one of this, what we can do is, if we take one and instead of x, substitute with the sum minus x, you will get the other one. So these two functions can be interchanged. So that is a direct application. So wherever you see a question with two terms or more terms where they can be interchanged with, instead of x, you can put b plus a minus x, then that is where you apply it. Now Now I have taken three different examples. If you see, the limits are different. 0 to pi by 2, 0 to 2 pi and 0 to pi. Why is that? In these limits from 0 to pi by 2, sin x and cos x can be interchanged. 0 to 2 pi, you see sin x and minus sin x, these two can be interchanged. And how do we do that? Let us see. Take the first example. It is from 0 to pi by 2. And just consider the functions sin x and cos x. Okay, in the first one, instead of x, let us substitute the sum of the limits minus x. Then what happens? Instead of x, put pi by 2 minus x. So how is its sign determined? You have to see where this lies. 0, pi by 2, pi, 3 pi by 2. We used to call it the axe chart, which means here in the first quadrant all the trigonometric functions are positive. Here only cos and sec are positive. Here tan and cot are positive. And here the sign values are positive. So now, where does pi by 2 minus x lie? It lies in the first quadrant where all the values, all the trigonometric functions are positive. So it is sine, so it is positive. And whenever you see pi by 2, remember the trigonometric function gets changed. Sine becomes cos, tan becomes cot, it changes. But then whenever you have pi, the trigonometric value is retained. Sine is sine, cos is cos, tan is tan. But here it is pi by 2, right? So if it is pi by 2, sine becomes cos. So there you see you have arrived at this. You started with sin x, you substituted it with this, you have got this. Now come the other way. Take the cos x. Now substitute it with pi by 2 minus x. Where does it lie? In the first quadrant where all the values are positive. Then what happens? You see pi by 2, the trigonometric function is changed. So this becomes sin x. So you see what is happening here? From sin x to cos x, from cos x to sin x, we can make that journey. And similarly, the same thing, but from 0 to 2 pi. Then how does it change? Take 0 to 2 pi, then what happens? Then sin x will become minus sin x. Why is that? Take sin x, substitute 2 pi minus x. Where does 2 pi minus x lie? This is 0 and this is 2 pi. So 2 pi minus x means it lies in this area where only the cos functions and the secant functions are positive. So that means this is sine. That means sine is going to be negative. And then it is 2 pi. Pi, 2 pi, 3 pi, 4 pi. All of that, the trigonometric value is retained. So this is your answer. See, similarly from minus sin x to sin x, you can make that journey. Now look at the third question. It is 0 to pi. There, what is the change you will observe? The change you will observe, you can't see it here, but what happens is cos x becomes minus cos x. I will show you how it is. Take cos pi minus x. Again, where is pi minus x? It lies in this area where only sine is positive. So this is minus. Now it is pi. So the cos value is retained. So it becomes minus cos pi. So you see how they are behaving. Just watch out for that. You will usually see two functions, and in each function, if instead of x you add the limits and substitute the x with the sum of the limits minus x, you will get the other function. But then how do we proceed from there? That is what we are going to see. What is the first question? It is 0 to pi by 2. This is I. Take this as I. But what is also I? What is also I? If you substitute sin x by pi by 2 minus x, and you substitute this by pi by 2 minus x, and what happens then? In 0 to pi by 2, we saw 0 to pi by 2, sin becomes cos, cos becomes sin. So here 4 plus 3 cos x by 4 plus 3 sin x. So now you see you have got two different values. I is the same, but then for the I you have got two different values. What do? Suppose if this is the first equation, this is your second equation, add both of them. On the right hand side you get 2i, on this here on the left hand side you get 2i, and on the right hand side what do you get? Right, you have this. You have something in the form of log a plus log b. But what is log a plus log b? It is log a into b. Then what happens? What do you see here? The denominator, this and this gets cancelled, and this gets cancelled. So what you get is actually log 1, which is 0. So if 2i is equal to 0, then I also equal to 0. So that is your first answer. How do you deal with the second one? The same way. Take two values of I. So what is the first value? The first value is just with the ordinary x, right? E raised to sin x plus e raised to minus sin x. And the second I, how does the second I look like? The second I, where you substitute x with pi minus x, and here also wherever you see x you substitute it with this. So 0 to pi, what did we find? This was actually minus sin x, and this was this was your first function, and this became your second function. Adding both of them, what do you get? 0 to pi. What happens to the denominator? See both the denominators are e raised to sin x plus e raised to minus sin x. The denominators are equal. That means we can just add up the numerators. So this is your numerator. Now what do you see? You see that again cancel. This becomes 1, or in other words it is 0 to pi dx, which means on integrating you get x. So the answer 2i will be pi. So I will be pi by 2, right? This is your answer. Now we come to the third question. They all follow the same method. Now see I, 0 to pi x sin x by 1 plus cos square x dx. We start with an I, but what is also I? If instead of x you put pi minus x, then what does x become? X becomes pi minus x. What does this x become? Wherever you see x, put pi minus x instead. So what does this become? Sin pi minus x by 1 plus cos square pi minus x. But then what is this? Sin pi minus x, what was that? We found it to be just sin x. Just sin x. But what changes? Cos is what changes. Cos becomes minus cos. But then here it does not affect it. Why? Because it is cos square. During, if you consider the limit 0 to pi, cos x and minus cos x are interchangeable. Under the integration rules, they can be interchanged. But here it does not make any difference because anyways it is squared. So you are going to get the same denominator anyways. So what have we done? We have expressed I in two ways. Add them up. In the right hand side you get this. In the left hand side, what do you get? 1 plus cos square x is the denominator is same. So we just have to add up the numerators. So that would be plus pi minus x sin x dx. But then here you, what do you see here? You have a plus sin x, a minus sin x cancelled. So all you get is sin x by 1 plus cos square x. What do we do? From here onwards, there is no property. You just have to integrate it. Whenever you see such things, whenever you see such integrals, think of one thing. Find that one term whose derivative will be the other term. Cos x to be, say, u. Then minus sin x dx is equal to du. See, you have the sin x dx here. But then, very, very important thing. What should you worry about? See, you have to change this also. What is cos 0? Cos 0 would be 1. And what would be cos pi? It would be minus pi. So how do we interchange the limits, and what happens when we interchange the limits? We get a minus. So there is a minus here, that becomes plus. So simply your answer becomes a very neat integral. See, just this. And what is that? Tan inverse of u. And what is tan inverse of 1 and what is tan inverse of minus 1? Tan inverse of 1 is pi by 4 and minus 1 is minus pi by 4. You see what is happening here? You have two functions. When you start with one, can you arrive at another? See, randomly take this as I. But what is the other form of I? Instead of x, this is the fourth root, okay? Instead of x, add the limits and minus x. That means what? 5 minus x plus 4. That becomes 9 minus x here. And what happens to the denominator? The denominator also you have the same term. So that same term is repeated here. And then what happens to this term? Instead of x, sum of the limits minus x. That means what? 4 plus x. See, you have got the other value. There you have. So you have two i's. What do? Add up. In the left hand side you get 2i. In the right hand side, same denominator. What happens to the numerator? So what do you see? Numerator and denominator are equal, cancel, you get 1. So all you get on integration is just x. So that means when you integrate it, your answer will be 5. But remember, that is not I. I is actually 5 by 2 because this is 2i. Now look at this question. Usually we have two functions, right? The one of them which leads to the other. But here you do not have two. But then you can manage to get a 2. How is that? What is cot x? Cot x is root of cos x by root of sin x. Multiplying throughout by root of sin x, what do you get? 1, no, root of sin x plus root of cos x. So this is actually your I. But then look at the limit. We know that from 0 to pi by 2, we know that sine and cos can be interchanged. But then what about pi by 3 and pi by 6? Add them, you will still get pi by 2. So whether you are integrating from pi by 6 to pi by 3 or from 0 to pi by 2, your answer is anyways, you add them up, both of them is going to be pi by 2. So in this place also, with this limit also, sine and cos you can interchange. So what does this become? The same I, this is one I, right? So the same I, what does it become? Instead of sine x, you get what? Your denominator is retained. Your denominator remains same. So this is one I, this is another I. Add both of them up. Then what do you get? On adding up, what do you get? Both the denominators are same. So you take the denominators like this, and what does the numerators become? The numerators become this. Again, you can cancel everything, you will get 1. On integration it will give you x, and then applying the values you will get pi by 3 minus pi by 6, which is pi by 6. But then it is 2i, which is pi by 6. But what is I? It will be pi by 12. This will be your answer. With this we come to the end of this particular session, and we have 3 more properties to learn, which we will continue in next class inshallah. And today what did you learn? You learned how to split the limit, and for where is it applicable? It is applicable when your function behaves differently for different numbers. And what are the 2 examples we saw? The greatest integer function and the modulus function. And the next, what did we say? We saw interchangeable functions. If instead of x, if you add the limits and subtract the x from this, if you can interchange the 2 limits, then you can apply this property. And in particular, there is a particular application to it, and that is when it is taken from 0 to a. That is a particular application. We are just taking a to be 0, and we are only taking the upper limit. So then what do we have? Instead of x, you can substitute a minus x. This is just a just a follow up on this. Instead of getting 2 non-zero limits, we are taking the lower limit to be 0. That brings the number of properties to 5, and inshallah in the next class we will continue. Till I meet you again, you stay safe. Assalamu alaikum.